Yes?
Beautiful song, Laushi.
Yeah, it's a beautiful song. I know most of you cannot understand the meaning of the song, but maybe after some Chinese classes, and you can understand it a little bit. So, so now let's start our lesson today. And last week we have learned the definitions of the function and the definition of the limits. So now first we will review the definitions, especially the definition of the limits. So now please do the following three exercises and write your procedure on the paper and send it in the WeChat group. Let me check if you can remember how to calculate the limit of a function. Okay, so now please do the exercises. If you have completed the exercises, you can send the procedure in the WeChat group.
Not yet, we are solving the questions.
Okay. Take your time.
Lakshmi, can you hear me?
Yes.
Lakshmi, I am in the roadside, so can I skip this one for a moment?
Sorry.
I'm in a roadside. I just got into some important things to buy for my parents. So can I skip this one, please?
Okay. Okay.
Thank you, Lakshmi.
The first student, you made a little mistake on the question number 2. Please check the picture I sent in the WeChat group. I think the first question is easy, just by substitution. So if you have finished the first one, you can set your procedure in the WeChat group and let me know, okay? Okay, I see most of you can finish the first one. So the first question, we just substitute x equals 1 into the function. So for the first one, I will write on the whiteboard here. And for the review part, the first one, find the limit of the function x minus 1 by x power 3 as x approaches 1, and we just substitute x equals to 1 into this function. So that equals to 1 minus 1 by 1 power 3. So that equals to 0 by 1. So equals to 0. This is the solution for the first question, and it is easy. And for the second one, I see some of you have finished it. The second question, that is here, as x approaches 0, find the limit of the function 5x power 3 plus 8x power 2, 3x power 4 minus 16x power 2. So that equals to, first, maybe you will think that we substitute x equals 0 into the function. So you can try it. Just substitute x equals 0 into the function. So you will find that is 0 plus 0 by 0 minus 0, right? So that equals to 0 by 0. And we know 0 by 0, that means the denominator and numerator must have the common factor. So here we know we first find the common factor. So that equals to, as x approaches 0, for the numerator, we find that we can take x squared outside. So that equals to x squared times 5x plus 8, right? And for denominator, we know that we can also take the common factor x squared out. So that equals to x squared times 3x squared minus 16, right? So here we find as x approaches 0, that means that x does not equal to 0. So we can see here x squared can be cancelled here. So that equals to 5x plus 8 by 3x power 2 minus 16. So now we can substitute x equals to 0 into the new function. So that equals to, we can just substitute here to see the result. So that equals to 0 plus 8 by 0 minus 16. So that equals to minus 1 by 2. So here, please be careful, don't make little mistakes, okay? So this is the solution for the second question. Can you understand the second one?
Yes,
Yes, Laoshi.
Yeah.
Laoshi.
Yes, we practiced similar questions last week, right? So you have to know how to solve this kind of questions. And for the third one, number 3, the limit that is to find as x approaches 2 and x power 3 minus 8 by x power 4 minus 16. So for this question, we can first substitute x
minus bq.
Yeah, you can first substitute x equals 2 into this function. You will find that is 2 power 3 minus 8 by 2 power 4 minus 16. And 2 power 3 equals to 8, right? And 2 power 4 equals to 16. So that is also 0 by 0. So if you see 0 by 0 type in the calculating of limit, that means you can find a common factor up and down. So now we look back to the function here. that equals to x approaches 2. Here, for the numerator x power 3 minus 8, that can be written as x minus 2 times x squared plus 2x plus 4, right? And for the denominator, x power 4 minus 16, that can be written as x squared plus 4 times x squared minus 4, right? And here you will find that x squared minus 4 can be written as x plus 2 times x minus 2, right? So that equals to x squared plus 4, then times x plus 2, x minus 2. So now we can find the common factor, that is x minus 2, right? So x minus 2 can be cancelled here. So we know that equals to the new function. And now you can substitute x equals 2 into the function to get the final result that equals to 2 squared plus 2 times 2 equals 4 and plus 4 by here that is 8 times 4, right? So that equals to 12 by 32, so equals to 3 by 8. So this is the solution of the third one. Can you understand?
Yeah, Laushi.
Yeah. So first,
No, Laushi.
yeah.
Can you repeat, please? On more.
Repeat
Yeah,
the
Laushi.
first step.
Yeah, yes, fast start.
Yeah. I know. Firstly, if you want to solve this question, you have to know that x power 3 minus 8 can be written as x minus 2 times x squared plus 2x plus 4, right? This is the basic knowledge to solve this question. So x power 3 minus 8, and 8 can be written, so first you can see x power 3 minus 8 can be written as 2 power 3, right? So here I will give you a formula for this kind of question, and the formula that is a power 3 minus b power 3. So somebody knows the formula for this kind of function, how to rewrite it?
Yeah, Laushi.
Yes.
Yes, right? So a power 3 minus b power 3 can be written as a minus b, right? Times
A squared plus AB plus B squared.
squared plus
AB plus B squared.
yeah, plus ab plus b squared. So this is the formula for this kind of function. So you have to remember this formula first.
Okay,
Laushi, I
Laushi,
have
now I
question.
got it.
Pardon?
Okay, I have question.
Okay.
Why we didn't apply in second line the s square plus b square formula in x square plus 4?
Here, the second line.
In
So
second line?
yeah, here, right? Second line.
Yeah.
Yeah.
First portion x square plus 4.
Plus
Why
4.
didn't we apply s square plus b square formula?
Here, x squared plus 4, you cannot rewrite it in the real numbers. X squared minus 4, you can rewrite it as x plus 2 times x minus 2, right? But x squared plus 4, you cannot rewrite it.
We can write x plus 2, x plus 2, double.
G.
You can rewrite it as
No.
what?
We apply this s a plus b whole square minus 2ab. X square plus 2 x plus 2 whole square minus 2ab. It's a formula.
Formula that is a squared minus b squared.
Equal
That-
a plus b into a minus b.
Yeah, that equals to a plus b times a minus b. But if here the sign is plus, you cannot separate at this one. Use this formula.
Okay, got it.
Okay.
Indamamul.
G.
Here the formula
a
is
square
here.
plus b square এর কোনো উৎপাদকের সূত্র নাই, তার জন্য এটা হবে না।
Okay.
The sign must be minus. Yes.
Okay, got it, Loshi. Thank you.
Okay. Any questions for this question? Okay.
No, Laoshi.
Okay, good. So for this kind of questions, you have to know the basic formulas and try to solve this one. So this is what we have learned last week, and we have learned the descriptive definition of a limit. So here we can review it. The limit of a function fx as x approaches x sub 0. That means as x approaches x0, the value of f of x approaches a fixed number. So we call this number the limit of this function as x approaches x0. And you can see here, x approaches x0, the real line here. If this point, that is x sub 0, then if x approaches x0, we can approach from the left or approach from the right. So here, there is another definition for the limit. We call it one-sided limit. And if x approaches x0 from the left, we call it left-hand limit. And if x approaches from the right, we call it right-hand limit. So here, x approaches x0 from the left. From the left, that means x is smaller than x0. So here I will give you two more definitions. The first, that is left-hand limit. Left-hand limit means x approaching x0 from the left, and that means x is smaller than x0. So here, if as x approaches x0 from the left, and the value of the function always approaches the same number, we call it the left-hand limit. So we can write like this. Limit the function fx. They are the same as before, but here x approaches x0 from the left. Here we write minus here, and equal to 0, equal to L. L is a constant. And similarly, we have right-hand limit. That means x approaches x0 from the right. And here, x is larger than x sub 0. So here, if we have the limit, that means as x approaches x0 from the right hand, the function approaches a fixed constant. So here we write plus here, plus here. That means x approaches x0 from the right hand. And here, the properties of the limit of the left hand limit and right hand limit, they have the same properties as the limit of the function. So here I will show you the limit law. The limit law of a function. So here we have sum rule, difference rule, product rule, constant multiple rule, and quotient rule. So here you can see, I will make it bigger. You will also find it from your book here. That means the first one, sum rule. That means here, the sum of two functions. If you want to calculate the limit of the sum of two functions, that equals to the limit of fx plus the limit of gx. So that equals to L plus M. So difference rule, that is similarly here, and product rule here, and constant. Here, K is a constant. So you can take the constant outside the limit sign. So here, limit x approaches c k times fx, that equals to, you can take this constant outside. So that equals to k times limit x approaches c f of x. Here, the limit of f of x equals to L, so that equals to k times L. Quotient rule, that is similarly, that equals to L by M. And also we have power rule. That means here, you can calculate the power at last. First, you calculate the limit, and then you calculate the power. So it is the limit laws for the limit of functions. And so the one-sided limit, they also have the same laws as here. So you can also use it. And next, last weekend we have learned the SUES theorem. And next, we have this theorem, and this is the way to check if a function has the law, if the limit of the function exists. So here I will write it again on the whiteboard because that is important here. So here it is a theorem to check if the limit of function exists. So if we say the limit of a function that exists, the limit is the constant L, that means the left-hand limit and the right-hand limit, they are exist and they are the same. So here, that means the limit of the function as x approaches x0 from the left hand equals the limit of the function x approaches x0 from the right hand, and they have the same limit L. So if we want to check if the limit of a function exists, we must check the left-hand limit and the right-hand limit, and they are the same. So the steps, that is first to calculate the left-hand limit, the second step to calculate the right-hand limit, and the third step to make sure that the two limits are the same. So we can say the limit of a function as x approaches x0 equals to L. For example, here, see the first one. To prove the limit does not exist. So this is the first example, and I will show you how to check it, how to prove it. So here, first listen. The limit, that is, as x approaches 0, absolute value of x by x. So here I have the first question, and we have learned last week. Do you remember the meaning of absolute value of x? Do you remember that?
Yes, Laushi.
Yeah.
Yes, Laushi. X.
Laushi.
It is same X.
Yeah. We call it piecewise defined functions, right? And that equals to, if x is larger than 0, that equals to x. And if x is smaller than 0, that is minus x, right? Remember that?
Yeah, Laushi.
Okay.
Yes, Laushi.
Okay.
Yes,
So
Laushi.
by the theorem, we want to prove the limit does not exist. So we first calculate the left-hand limit. So here, the solution here, we first calculate the left hand. So left hand, we write minus here, absolute value by x. So that equals to, here, if x approaches 0 from the left hand, that means
Minus 6.
yeah, that means x is smaller than 0, right?
Yes.
Yes.
Yeah, right.
If x is smaller than 0, then absolute value of x equals to
Minus 8.
X.
Yes. So that equals to minus x, right? And x is still x here. So x can be cancelled. We know the limit of the left hand, that is minus 1, right?
Yes.
Yeah, minus 1. And then we calculate the right hand limit. And we write plus here. That means right hand limit. So that equals to, if x approaches 0 from the right hand, that means x is larger than 0. Yes, so absolute value of x
Equal to X.
yeah, excellent, x here. That means x by x, so x can be cancelled, that equals to
1.
1.
Yeah, so here we can see the left hand, the limit, the left hand limit is minus 1, and the right hand limit, that is 1. That means the left hand limit of this function does not equal to the right hand limit of this function. So we know the limit, therefore, we know the limit of this function as x approaches 0 does not exist. Because the theorem tells us the left-hand limit must equal to the right-hand limit. We call the limit exist. That means the limit of a function that is unique, right? they have, yeah, that
Yes.
it has only one limit here. So for this question, we know the limit of this function does not exist. Can you understand, guys?
Yes,
Yes.
Okay. Okay. So if I am clear,
Laushi, I have a question.
yeah.
If both of them limits are not same, like left hand limit and right hand limit are not same, then it does not exist. Am I right?
Yes. If the left limit does not equal to the right limit, then the function, the limit of the function does not exist.
Thank you, Laushi.
Okay. Welcome. So now please do the exercise by yourself. The second one. Here, I also gave you a function, f of x, and that's also a piecewise function, this one. That is also a piecewise defined function. So here the question, does the limit exist? If so, calculate the limit. If not, tell me why. So practice the number 2 question. Do you want to see the procedure of the first question or see the questions? Here the solution for the first question.
Laushi, we didn't write the question.
I have pointed out some mistakes in the WeChat group. And I think the question is not so difficult, but you have to pay attention to the writing. So here, for the solution of the second one, here. So here, first, we know that the function, this is the function f of x equals to x minus 1 if x is smaller than 0 and 0 x equals to 0 and x plus 1 if x is larger than 0. So here, you know that first we calculate the left hand. Left hand here, we usually write the sign limit and then write the x approaches x0 here at the bottom. And the limit sign that is larger than here, the bottom. And here, don't forget to write the function f of x. And if x is smaller than 0, we know that the function equals to x minus 1, right? So here you write x minus 1 here. And don't forget to rewrite this one, this condition. And that equals to 0 minus 1 equals to minus 1. So similarly, we can have the right-hand limit. Pay attention to the writing. So that equals to limit x approaches 0 from the right hand, x plus 1. That equals to 0 plus 1 equals to 1. And since the left-hand limit does not equal to the right-hand limit, so here you have to write the complete formula. That means x approaches 0, x approaches 0. Since we found the left-hand limit does not equal to the right-hand limit, we have the limit of the given function as x equals to 0 does not exist. Does not exist. So here is the solution for this question. And for the examination, you have to write the complete solution here on your paper, on your answer sheet. Okay, guys? So this is the left hand and the right hand limit. And then I will give you one very important formula, and this formula is shown on the book as Theorem 7 here. This is the important formula, and you have to remember it clearly. So here I will rewrite it again. We call it important, one important formula here. This is very, very important. We can use this formula to solve many questions. So I gave triple star here. So the formula that is the limit of sine x by x as x approaches 0 equals 1. The limit of this function is 1. And the proof of the limit you can see from your book. And I will not write here. But for this formula, you have to remember it carefully. And you have to know how to use this formula to solve other questions. For example, the first one. the first one, to get the limit of x by sine x as x approaches 0, the first one. So here I will solve here. If you want to use this important formula, you have to get the same type, the same form as the formula. So here you can see the function here that is sine x by x, right? So we want to get sine x by x function. So here, how to get the same function? We can divide x both up and down. So we can divide x both up and down. So for this step, can you understand how I get this one? Yeah, because x approaches 0, that means x does not equal to 0, right? So I can divide it both up and down. Can you understand?
Yeah, that's it.
Yeah, okay. And then that equals to here. Numerator here, x can be cancelled, so that is 1, right? And here denominator, that is sine x by x, right? Here we will use the quotient law, the quotient rule, the quotient rule. The quotient rule I have shown you at the beginning of the class. Here, number 5, the quotient rule means the limit of a function fx by gx that equals to, we have the limit L by M, right? So here, we can use this law that equals to here, limit x approaches 0, 1, here is 1, right? And by limit x approaches 0, sine x by x. So for these two steps, can you understand?
Yes, Laushi.
I could not understand second step.
Yes, Laushi.
Okay, so you cannot understand the second line, this one, right? But
Second step. X by x, you divide by x by x.
yeah,
That one.
x by x, that equals to 1, right? So here that is 1. And sine x by x, we don't change it. So here.
I said this one. How did you find? How did it come?
Annotate.
We just divide x both up and down here. That is also the same because we divide the same number, the same value here.
Okay.
অবহরকে x দ্বারা ভাগ করে
মানে দুই পক্ষকে x দ্বারা ভাগ করে
হ্যাঁ
দুই পক্ষ না, উপরে নিচে হরলব x দ্বারা ভাগ করছে
লব ও হরকে
ওইটা নেওয়া যায় আগে
হ্যাঁ
Okay, guys.
Okay.
So, other questions?
Okay. Thank you, Laushi. I have got.
Welcome. Please remove this right line, okay? Okay, then we got this step. And here, we have to know that, can you remember the limit of a constant function that always equals to the constant, right? We have talked about it.
Yes, Laushi.
Yeah. Yes, we have talked about last week that as x approaches x0, the constant limit always the constant, right? So here we know the up one, that is 1, right? The limit equals to 1. And here, denominator, the limit that is 1, also 1, right? From the formula. So we know 1 by 1 equals 1. So we can get the limit of the function x by sine x as x approaches 0 equals to 1. So This is how I solved the first question. Use the formula. Can you understand, guys?
Laushi,
Yes,
again, please
Laushi.
repeat last line.
Last line here.
Yes, yes.
Yeah. The up, the numerator, that is because 1 is a constant function. So the limit is this constant 1. So we can get 1 here. And the denominator, we from the formula here I have gave you, and you can use it directly. So you have to remember that sine x by x as x approaches 0 equals to 1. So we can get 1 here. Then 1 by 1 equals 1. That is how I get that. So which part you didn't understand?
Oh, okay, Laushi, got it.
Okay. So other questions?
Laushe, I have a question. Sorry.
Yeah.
How do we get? May I write this part? How we get this? Because y it equals 1.
Okay.
Because yeah.
Okay. That is what we have learned last week. Here, this is the function. This is the formula here. C means a constant. So here, C equals 1 here, right? And C is a constant function. That means y always equals to C. Fx always equals to C. So no matter how x approaches x0, and no matter what value x0 is, y always equals to C, the constant. So we know the limit that is C. For example, I will draw an example here. For example, I gave you a function that is fx equals to 1, or we can write as y equals to 1. And here, from the graph, we know y equals to 1. So the line, this is the graph of this function. No matter what value x equals to, for example, x can equal to 1, 2, 3, and so on. No matter which one, y always equals to 1 here. Y always equals to 1 here. So the limit is always 1 here. So for this one, here x approaches 0. This is 0, right? No matter no matter which side x approaches. Yeah.
Hi, I'm so sorry. I thought the class was at 7:50. I'm so sorry. I didn't know.
Doesn't matter. Okay. Okay.
You missed the test.
Okay, then here we have the limit is always 1 here. So can you understand?
Yes, Laushe, thank you.
Okay. So other questions for this one? Other questions? No, good. Okay, so now let's practice the second question here. This one. Let me find it. Number two. Okay, I will write it on the whiteboard. Number 2. To calculate the limit of tangent x by x as x approaches 0. So here, when we solve this kind of questions, you have to always remember that we want to use the formula here. And the formula, the function that is sine x by x. So you have to find sine x by x in the given functions. So here we can think that tangent x equals to what? Remember that?
Sine divided cos.
Sine by cos.
Yeah, that equals to sine x by cosine x. right? So here, I can rewrite this function x equals to 0 as sine x by cosine x, and here is still x, right? So here times x, x, x. We don't change it. And then we want to rewrite it again to see more clear. That is, as x approaches 0, sine x, we take these two parts together. So that equals to sine x by x times 1 by cosine x, right? So can you understand from the second step to the third step? Can you understand?
Yes, Laushi.
Yes, Laushi.
Laushi, I have a question.
No,
Yeah.
I didn't understand.
Okay.
Laushi, you said tan x is equal to sine x divided by cosine x.
Yeah.
And the question was tan x divided by x. And as you rewrite it, you wrote it sine x divided by x cosine x. And I want to know why wasn't it divided by x, but it was multiplied by the x.
So you want to cancel x here?
No, I wanted I thought you would rewrite it sine x divided by cosine x,
Yeah, sine
all
x.
divided by the x.
Yeah, and then by x, right? By x.
Yeah.
Yeah.
Yes.
Yeah. Yeah. And this kind, I can also write like this, right? They are the same. They are the same.
Okay, Laushi. Okay, Laushi. I'll get you right now.
They are the same.
Okay, Laushi.
Okay, and then we can use the formula, because here we can first use the product rule. That equals to the limit of sine x by x times the limit of 1 by cosine x by the product rule, right? Separate it. And then here from the formula, we know the result that is 1, right? And here we can substitute x equals 0 into this function. And remember that cosine 0 equals 1.
1.
Yeah, cosine 0 equals 1. So here the limit is 1 by 1, so equals 1. We know that equals 1 times 1 equals 1. So we can get the second result, that the limit of tangent x by x equals 1 here as x approaches 0. So for the second question, can you understand?
Yeah, Laushi.
Yes, Laushi.
Good. Okay, so here for the first two, I show here the result for the first one that equals to 1, and the second also equals to 1, right? And these two results, you can use it directly if you can remember it. Okay, you can use it directly if you can remember it. Tangent x by x, as x approaches 0, the limit is 1, and x by sine x, as x approaches 0, the result is also 1. So here is the two exercise. We use the important formula. Then please practice more and do the exercise number 3 and number 4 here.
Right now, was she?
Yeah. First, number 3. Maybe number 4 you will feel a little bit difficult. Number 3 first.
She is number 3 is equal to 0.
Equal to 0? No. Hey, let me check. Yeah, 0, right, 0. Okay, guys, you did better than I thought. So here I will give you the solution for the question number 3 here. The result, the limit is 0. Here, number 3. Okay, to calculate the limit of, let me see the question, that is x approaches 0, x squared minus x plus sine x by 2x, right? So first, for this question, you can separate the function first here for this part. And for this part, you can rewrite the function like here, remember to write the limit larger and x approaches 0 smaller at the bottom. Okay, this is the sign. And then we can rewrite the function part by part, right? Because here, for example, b plus c by a can be written as b by a plus c by a, right? So here we can rewrite the function as 3 parts. The first part, that is x squared by 2x, right? Minus x by 2x and plus sine x by 2x, right? So here we know for the first part, x can be cancelled. And for the second part, x can also be cancelled, right? So here we can use the difference rule, that is limit x approaches 0, the first part, that is x by 2, right? Minus limit x approaches 0, 1 by 2, and plus the last part, that is limit x approach 0, here sine x by 2x, right? And the first, as x approaches 0, here we know that equals to 0 over 2, right? And minus here, 1 by 2 is a constant, right? So that equals to 1 by 2. And plus here, that equals to, here we can see sine x by 2x. Here, this part. Sine x by 2x can be written as 1 by 2 times sine x by x, right? And 1 by 2, that is a constant, right? We can take this constant outside the limit sign. So that equals to 1 by 2. Limit x equals approaches 0. Here, that is sine x by x, right? And here we can use the formula, this part equals 1 here. So we know the final result, that is minus 1 by 2 plus 1 by 2. So that equals to 0. This is the solution for the third one, the third question. So, do you have questions? Do you have any questions here?
I could not understand last line. How could I get 0?
The last line.
Plus half and minus half.
Here. You can understand here, right? 0 by 2, we substitute.
And what is this one? Sin x by x?
That is the important formula above. That is what we are learning about, right? This one. Remember that?
Sin x by x, yes.
Yeah,
I can remember.
X by x, the limit equals to 1, right? So here, when we take the constant 1 by 2 outside the limit sign, that equals to 1 by 2 times the limit of sine x by x, right? And
yes.
sine x by x, the limit equals to 1. So here
yes.
It is 1 by 2 times 1. So equals to 1 by 2. So here that is 0 minus 1 by 2 plus 1 by 2. So equals 0.
Thank you, Loshi. I have got.
Other questions?
No.
Okay. And for the last question, here I will give you a hint, but I see some students have worked it out. That is really excellent. So here, look back to the question here. We want to calculate the limit of sine square root of 2x by square root of 2x. So here we can find that square root of 2x, square root of 2x, they are the same, right? So here we can let another letter may be y or letter t. Any letter is okay here. So here I will write on the whiteboard. for the question number 4, that is, we first let t equals to square root of 2x, right? And the original function, that is sine square root of 2x by square root of 2x as x approaches 0, right? Here, so that equals to the limit. We first change the function. Here, sine, we let t equals to square root of 2x here. So here we change it to sine t, right? Here is t. And square root of 2 t x equals to t, so here that is t. And then don't forget to change this part, because here the variable is t. Here the variable is t, not x here. So you cannot write x approaches 0 here. That is not correct. Then you can find if x approaches 0, then because square root of 2 is a constant, right? So square root of 2 times x also approaches 0, right? And that means t approaches 0. Because square root of of 2 is a constant here, it will not change. Square root of square root of 2x approaches 0. So here t approaches 0. And now we know.
Lordship, please repeat again.
Repeat it again. Okay.
Okay, Lordship.
Okay, here, as x approaches 0, as we have given the condition here, and here the variable that is t. So we want to know t approaches which value. So here we can find if x approaches 0 here, then square root of 2x, here, x, we times the constant here, that also approaches 0. You can take special number here. For example, if x, that means here maybe 2, 1, 1 by 2. That means approaches 0, right? Or next one maybe 1 by 4, so on. And if we times square root of 2 to each value, that means 2 times square root of 2, and square root of 2 by 2, and square root of 2 by 4. That also approaches 0, right? So we know that will not change. Or you can use it as here. So here you know that t equals to square root of 2x. So we know t also approaches 0 here. And here x approaches 0 and we want to change it, that x equals to 1 by square root of 2t, right? We take square root of 2 from the right to left. So x approaches 0, that means t also approaches 0 here. So here we can find that is the same type of the important limit. So here we know that equals to 1. Because the important limit, the formula that we gave, that is sine x by x as x approaches 0 equals to 1. And here we just change the letter from x to t, but that will not change the limit. So that also equals to 1 here. So here you will know that a more general form of the formula, that is, as long as here here, they have the same thing. Then the limit is 1. No matter here how I write it, as long as these 3 parts are the same, then the limit that is 1, because we can always let another variable to be here. So that can be the same formula. So after the break, we will practice more exercises to let you know the more general form of this formula. Okay, guys?
Okay, Laj.
Okay, Lash.
Okay, Lausin.
Okay, so now we will have,
How
yes?
many times we get the break?
Yeah.
20 minutes, Laushi.
How many minutes? How many minutes?
15 minutes here.
Wow, 15 minutes.
Okay, so here we will have 15 minutes break.
Okay, watch it, sure.
Later.
এই বাংলাদেশি পোলাপেন গুলা কই আমাকে
আরে বাবা
ওমর ভাই
আজকে হচ্ছে পোলাপাইন দেখি যে বেজেছে না কই পোলাপাইন
পোলাপান শক্তি শেষ
আমি শেষ আমি শেষ
এই আলাম খালি ঠিক আছে আলামিন ভাই একটা বাইরে বাইরে দিচ্ছে
আলামিন সারাদিন অফিসে থাকে
রে ভাই তোমরা যারা
চাকরিজীবী মানুষ
তোমরা যারা অটো পাস করছো ও তো মোটামুটি হচ্ছে তোমার ফাংশন গুলো রিমেম্বার আছে, কিন্তু আমরা যারা হচ্ছে লেটলি লাইক হচ্ছে 18তে এইচএসসি দিছি এন্ড 16তে এসএসসি দিছি ও হচ্ছে আবার আমার হায়ার ম্যাথটা রিভিউ পুরো বইটা রিভাইজ দেওয়া লাগে। না হচ্ছে আমি আমার এই যে এখন ম্যাম বললে মনে হয়, কিন্তু পরে আবার ভুলা যায়, এগুলা অনেক প্র্যাকটিস করা লাগবে আমার।
ম্যাথ প্র্যাকটিস ছাড়া আসলে কখনো মনে থাকা সম্ভব না।
পুরো শেষ।
আমি ধরো তোমার 18 পরের থেকে এই ইউরোপে যাওয়ার ধান্দায় শুধু হচ্ছে খালি ইচ্ছারমে আলসে পড়াশোনা করছি, খালি অ্যাপ্লাই করছি ইউনিভার্সিটিতে, এইগুলা যে প্র্যাকটিস করা লাগবে এই সব ফালেন। এখন হচ্ছে আমার পুরোই পড়া যাবে।
আলামিন তুমি এটা কি দিতেছ?
কাম করতে আসছি।
আলামিন
স্যামসাং
তুমি কি স্যামসাং নাকি?
ইয়াপ
আচ্ছা আচ্ছা আচ্ছা
একটা স্ট্যান্ডার্ড পাঠায় দাও আমাদের জন্য।
আমি হচ্ছে ইয়া করে চালাই, গরিবি হালাতে চলতেছি। কয়দিন আগে ফোনটা নিয়ে গেল না।
ও আচ্ছা, তোমার তো মোবাইল
এই 52s নিয়ে যাবো ভাবতেছি, আর নাইলে হচ্ছে ইয়া নোট 20 আলট্রা।
ভাই ওইখানে গেলে বহুত পাতা।
না ওইখানে গেলে তো আইফোন, এখানে হচ্ছে
কোনটা নিবা?
আইফোন
অ্যাপল
এখানে আই এম নট শিওর, এখন আমি ইয়া না, কারণ কি বলে ওই চাইনিজের ওদের অ্যাপ মিলে সব হচ্ছে একটা ইন্টারন্যাশনাল ইকোসিস্টেমে থাকতে হবে। সো ইউ হ্যাভ টু গো টু আইদার স্যামসাং অর অ্যাপল। অ্যাপল ইজ বেস্ট আই গেস এভরিওয়্যার, বাট
মানে আলামিন ভাই নিজেই কি দিব?
তুমি মে স্যামসাং এর এমপ্লয়ি বা অ্যাপল এর চিন্তা করতেছো?
আচ্ছা
এটা চা খাও তো।
এটা মানা যায়?
ওমর
আচ্ছা আমি একটু কিছু খেয়ে আসছি, বুঝছো?
ওমর
ভাই জোরে নামে চুপ রয়েছে।
ও আচ্ছা হ্যাঁ যাও।
আমার এগুলো শিখতে হবে ভালো মতো ভাই, প্রচুর শিখতে হবে।
আমার হচ্ছে আমি প্র্যাকটিস না করতে করতে আমার পুরো অবস্থা খারাপ হয়ে গেছে।
এই টপু
হ্যাঁ ব্রো।
টফু তুমি আসছো?
আছি
আজকে
এটা
দেখতেছি
লুঙ্গি পরা, এখন প্যান্ট পরতেছি আর কি।
আচ্ছা আচ্ছা नीचे के जाएंगे पे तो देखो
না
bye I'll be right back.
Ekonoani.
Bro,
Bro, awesome. How is the class going?
I came late, so I'm just confused.
Yeah, you are just catching up.
Yeah.
Bro. So almighty
Right?
mathematics. Almighty mathematics. Oh, but you nail it. As time goes on, you nail it.
You're going to have to explain for me, bro.
Because as the class that I was just getting a bit confused, but right now I'm getting it.
That's what's up.
Yeah, bro.
You should take
The
me up
math
to the
there for master. You have to master the math.
It's
Oh,
giving
bro.
me.
You see, now I've got code. It rained yesterday, but the math is even getting making it worse. Bro.
This math is giving me head.
No, it's not easy. It's not easy. Like, but I'm getting it at science over science, replacing it and those steps. I'm getting it.
Yeah, and I'm sure the code will go away.
Oh, my bro, it's early here. So what's the time at your place?
You should text me after the class.
Okay. I'll test it.
Yeah.
Because it's 7:30 a.m. here.
Oh.
Yeah, so the class started around, I think, 5:30 in the morning.
So you had to wake up very
early. Yeah, you did. 5:30 in the morning. So if you make a little mistake there, the class will be over before you even get to realize.
I came
all right.
And I was just confused, like, what's going on?
Yeah. But today's lesson is a bit more of revision of what we did last week. Yeah. And today's one is not difficult as the first one.
Yeah, you have to explain for me.
Bro. Because today I'm turning all my focus and attention on this mathematics.
Yeah, it's needed. It's needed.
We can hear you, Kandani.
We can hear you, Laushi.
Okay, so you feel confused for the last question? Okay. I will explain it again.
Okay,
for the last question, right?
Yes, Laushi.
Okay, so you are confused about here, right? Maybe most of you may be confused.
Yeah, Laushi.
Because here t, that is square root of 2x, right? And t here also square root of 2x. So that is the same. We just let t equal to this part. And y here, t also approaches 0. Let me show you by the graph. Okay, here, I will draw the graph here. here, guys, maybe I can think that x is a function. So we can let y equals to x. So you can see here, this is the graph of y equals x, right? And as x approaches 0, y also approaches 0, because you can see here, maybe if x equals to 1, that y also equals to 1 here, right? And x equals to 1 by 2, that y equals to 1 by 2, right? So if x approaches 0, y also approaches 0. So can you understand this part?
Yes, Lashi.
Yes, Laoshi.
Okay, so here t equals to square root of 2x. So we know that square root of 2, that is larger than 1, right? So maybe the graph of square root of 2, that is here. This right line. This is y equals to square root of 2x. So here you can see this line. Okay, so as x approaches 0, that means maybe first, if x equals to 1, that you can see y equals to square root of 2 times 1. So it's square root of 2, right? And if x equals to 1 by square root of 2, 1 by 2, so here y equals to square root of 2 by 2. So you can see if x approaches 0, that y also approaches 0 too. So that means here I use t here. That means t approaches 0. And here t, that is square root of 2x. So can you understand? You can still not understand? Guys?
Yes, Lashi, we got it. We got it, Lashi.
Okay, okay.
Laoshi, we have to discuss from beginning.
Can you repeat, please?
Repeat which part?
From beginning, Laoshi.
Beginning, which beginning? Okay, okay, here. Okay, so you're late. You missed the beginning, right? I mean, I am explaining why x approaches 0, t approaches 0. That means here you can draw this line. And this is the graph of y equals to square root of 2x. Here, we can use t here. T equals to square root of 2x, as here, the same. T equals to square root of 2x. And if x equals 1, we can take here, that is square root of 2, because square root of 2 times 1 equals to square root of 2. That is t here, right? And if I take x equals to 1 by 2 here, that t equals to square root of 2 by 2. So you can see, as x approaches 0, y also approaches 0. Y gets smaller and smaller, and gets close.
You can delete it. You can delete it and repeat the draw.
Sorry. I cannot hear clear.
We cannot see your arrow chino because it is full of color.
Okay.
So you can delete it and then again draw it.
Please don't erase it, Laoshi.
Mm-hmm.
And let's begin.
Yeah, I will give you guys the recording and the whiteboard. Okay, other questions here?
Laoshi, I think you can give us the other example with the same method.
Of course. of course. Okay, so now I will give you more exercises here, but you have to know the formula first, this one, and the second one that is a more general one. That means here, sine, here, I use a square to mean as long as these three parts are the same, then you can get the same result, that is 1. So these two formulas, actually they are the same, but they have different form. Okay, so now I will give you more examples. For example, here, the first one. And the first one, I will show you how to solve it, and then you can solve other exercises. So first, the first one, that is limit sine kx by x approaches 0. Am I right? Yes. Okay, here, k is a constant. So here, that means k can be any value, any constant. Maybe k can equal 1, 2, 3, 4, and so on. So k stands for a constant here. And then if I want to use the formula, you can see here. Here we can find that kx here, right? And if we want to use the formula, we want these three parts are the same. So here, for the denominator, we also want kx here. Can you understand? If we, yeah,
Yes,
if we want
Rashi.
to use this general formula, that these two parts must be the same. So here we can see that is sine kx, right? So we want kx as denominator here. That means they are the same. Can you understand, guys?
Yes,
Yes,
Roshi.
Yes,
Yeah.
Rashi.
But the original function, that is sine kx by x, right? They are not equivalent, right? So
Yes,
to
Rashi.
make these two parts equivalent, we must times k here. Because k is a constant and k can be cancelled, then they are the same, right?
Okay.
Can you understand? Yes. So here I rewrite the function as this form, that is sine kx by kx, then times k, because I want to use this formula, but I cannot change the original function. So I write kx as denominator and then times k. And don't forget to write the limit sign. And here, I also want this part is the same, right? So here, we know if x approaches 0 and k is a constant, then kx also approaches 0, right? So here,
Yes, right.
yes, so here, because k is a constant, so I can take the constant outside. So that equals to k times limit sine kx by kx. Then here I rewrite it, kx approaches 0 here. Can you understand?
Yes.
Yes.
Yes, Rashi.
Okay, so here, from the formula, the limit here, that equals 1, right? So
Yes.
that equals to k times 1 equals to k.
Yeah.
Yeah. So if I ask another question, that is to calculate the limit of sine 3x by x as x approaches 0, then the answer must be
3.
3, right?
3.
Yes, 3.
Yes.
Because here k
Yes.
equals 3 here. Can you understand?
Yes.
Yes.
But
Yes, Laoshi.
Yes.
but there is one more thing. That does not mean
So,
x can
Lashi,
be
this is
cancelled
more like
here.
the constant
X
formula.
cannot be cancelled here because sine 3x does not equal to 3 sine x. They are not equivalent. So remember that.
Okay.
If you write as the solution here, it is correct. But if you write like this, it is wrong. I will not give you 1 mark. Remember that? So this is not correct. This is not correct. They are not equivalent. We get the same result, but this is totally wrong. Okay, guys?
Okay.
Okay, so here is the right procedure for the question. Okay, and then please calculate the following limit from number 2 to number 6. Yeah, I saw somebody says a Chinese, right? But I don't know if you can speak Chinese. And that means he cannot work it out. So let me show you number 2, question number 2. Okay, and then maybe you will find how to solve number 3. Okay, guys. So first let's solve number 2, the second question. Okay, the second question, that is limit sine 3y by 4y y approaches 0. Here, no matter which letter it is, x or y or t or any letter, it will not change the limit. So you can just remember recite one formula, that is okay. So the formula you should always remember here. If I want to use the formula, the general one, that is sine, these 3 parts should be the same. Then the limit is 1 here. So I want to use this formula. Then here I see that is 3y here, right? So guys, I will write here sine 3y by 4y. So I want to use this formula, so that is sine 3y. So please think about it. How I will say, how I will write in the denominator. Here, I want 3y here, right? I want 3y here. But here, that is 4. That means 1 by 4, right? And I write 3y here. So I must time 3 here. That can make 2 functions the same because 3 can be cancelled here, right? And 4y, they are the same. So here, that is 3 by 4 times sine 3y by 3y, right? So here we know that is limit y approaches 0.
This 3.
Excuse me, pardon?
Can
I
go
can't understand.
Here.
Yeah, I can understand.
Okay.
Yes, this line.
Okay. Okay, you don't know why I times 3 here, right?
It started from 1 by 4.
Okay, so I will rewrite it again and I will explain again. Please remove the circle. Here, if I want to use this formula, we know that these 2 parts should be the same. So here we say, we write sine 3y, we see sine 3y. So if I want to use this formula, here must be 3y, right? But the original function, that is 4y, right? So they are different, they are not the same. So I have to time some constant to make these 2 parts the same. So here you can see, I can rewrite this part here. Again, I first take the constant out. And the constant here, that is 1 by 4, right? So sine 3y by 4y can
now got it, Lord.
can be right as 1 by 4 times sine 3y by y, right? I take 1 by 4 out. So here, 1 by 4 is always here, but here I want 3y. So if I want 3y in
Okay,
the
Lashi, got it.
denominator, yeah, I must times 3 to make it the same. So I have 3 by 4 times sine 3y by 3y. So can you understand now?
Yes, teacher can.
Okay.
Yes, Lashi.
Okay. So here we have 3 by 4 sine 3y by 3y, right? And that equals to 3 by 4. This is a constant. I can take it out. By limit sine 3y by 3y. And if y approaches 0, then we have 3y also approaches 0, right? So now these three parts are the same. And we can use the formula that equals to 1, right, guys? So here that equals to 3 by 4. 3 by 4. And here, maybe you can have another solution, way 2. This is way 1, and this is way 2. Way 2, you can solve it like this. Sine 3. Okay. So what is the question?
This part that is my I marked.
This part, the limit?
Yes.
The limit, I don't change
Limit,
it.
3/4. Limit 3 0. This part.
Yeah, I have explained it above. As x approaches 0, that means kx also approaches 0, right? Here, the letter is changed. Y approaches 0. Also, we can have that 3y also approaches 0 here. So here you can write 3y approaches 0.
Okay, Lashi.
Okay. So here another way to solve
It's
it.
for constant, right, Lashi?
Yeah, it's a constant. No matter which constant it is, maybe 100, then 100y also approaches 0. And the constant can be very large. That will not change. Okay. And here y approaches 0, right? Here, you can first take the constant out because that can be written as 1 by 4 times sine 3y by y, right? And we can take the constant 1 by 4 out, equals y approaches 0 sine 3y by y, right? And guys, we have learned it. Here, we have calculated the limit kx by x as x approaches 0 equals to k, right? So here you can say sine 3y by y as y approaches 0 equals to 3, right? So that equals to 1 by 4 times 3 equals to 3 by 4. No matter which way you choose, you will get the unique value. So we say the limit only one. There is only one limit for the function. That is also 3 by 4. Can you understand, guys?
老师
Yes, okay.
明白了，老师。
Okay. And for question number 3. Question number 3 is similar to question number 2, right? So now you can try to solve it. Yeah, solve it by yourself. Okay. Sorry, the internet is not good, so I cannot hear you clear. If anyone can hear clear.
He's only saying
No, Lashi.
Yeah. I can't hear. Sorry. So
Maybe his network is not good.
yeah. Now we maybe you can type your question in the WeChat group, and we can or in the dialog box.
My network is absolutely good. I'm using.
Yeah. And the number three, maybe we can give the result directly. So do you get the limit? The limit is
2/5.
yeah.
Is it 2/5?
2 by 5. Yes.
Yes,
Why?
2/5.
Yeah.
Yeah.
Why 2 by 5? Because first.
Yes, Lashi, 2 by 5.
Yeah. Of course, there are 2 ways to solve it, right? Yeah. And here I choose the second way, and that is more simple, right? Here. So here I will write here. First, we can take the constant out. Which constant? That is 1 by 5, right? Limit x approaches 0, sine 2x by x. Right, guys? Here I must say it again that if you write like this, I will write here. If you write sine 2x by 5x, x approaches 0, 2 by 5, limit x approaches 0, sine x by x equals to 2 by 5. This is totally wrong. Guys, can you understand? Because I say sine 2x does not equal to sine x, 2 sine x. Because from the formula, sine 2x actually that equals to 2 times sine x times cosine x. This is correct. This is the right formula. This is wrong. This is wrong. So if you write like this, although you get the right result, but you cannot get any mark. Can you understand, guys?
Yes, 老师.
Okay. But this is correct. You can take the constant 1 by 5 out, and we know the limit of this one, that is 2, right? Because equals to k, right? We have solved it. So that equals to 1 by 5 times 2. So equals to 2 by 5. This is correct. So pay attention to this part. Don't write like this. This is not correct. Okay, guys?
Yeah.
Yes,
Okay.
老师.
Okay. And then question number 4. 1 minute. Oh, I see one correct solution. Okay, so we will solve number 4 and number 5 here. Okay, question number 4. Number 4, limit sine 2x by sine 3x as x approaches 0. One more thing.
Can I use here these rules 2 sin x cos x
Sine 2x, then
equal to yes sin 2x equal to 2 sin x cos x?
no, I have just told you sine 2x does not equals to 2 sine x.
Yeah, here you write sin 2x equal to 2 sin x cos x.
Which one? Yeah, that equals to here. Sine 2x equals to 2 sine x times cosine x. Yes, this
So number 4 sin 2x equal to
2
can I write
times cosine x. That is correct.
yes.
But how can you get sine 3x?
No.
Yeah, that is the harder part, right?
Yes.
So here we also want to use the formula. We want to use the formula. So I will write the formula again. That is sine. I also want to use this formula. Okay, so here I will treat this function as 2 parts. So here I will rewrite the function as sine 2x times 1 by sine 3x. They are equivalent, right? And then here, I want to use the formula here so that it equals to, here, I will not change x approaching 0. And here, I see sine 2x, right? So sine 2x. And if I want to use the formula, here must be divided 2x, right? Then I can use the formula, right, guys? And if I write 2x in the denominator, that to make it equivalent, I must times 2x. So this part and this part, they are equivalent, they are the same, right? So this is the first part. This is the first part. And then I want to show the second part. For this part, guys, maybe you can remember the exercise I gave you above. That is exercise number 1. Here, limit x by sine x as x approaches 0 also equal to 1, right? Remember that? And I have told you that you can use this result directly. Here, also the same, that is as long as these 3 parts are the same, the limit is 1. So here we can say that is sine 3x, right? And if I want to use this formula here, I want 3x. But to
I
make
could not understand second line, Laushi.
which
Same here.
here we have
Second line sin 2x by 2x multiply 2x. This one.
this one, right? because we want to use the formula here. We want to use this formula. So here, sine 2x, then we have to divide 2x here to make the same form of the formula here. But if we divide 2x here, we must times 2x to make these two parts equivalent. Right?
Yeah.
Can be cancelled. Yeah. So.
And second part, how can I write 3x by sine 3x?
Sine x.
He's not finished yet.
Yeah.
Okay, thank you.
Yeah, I'm not finished. Don't hurry, okay? So here, this is the first part. And the second part here, we want to use this formula. Similarly, we have 3x as new numerator, right? And then to make these two parts equivalent, the same, we have to time 1 by 3x. These two parts are the same, right? Because 3x can be cancelled. Right, guys? So the next step, I will change the terms, change the order of the functions. So next step, I will write here, that equals to x approaches 0. The first, I will write this one, that is sine 2x by 2x. And then I will write this part, that is 3x by sine 3x, right? And I will write this part, 2x. And I will write this part, 1 by 3x, right? So here you can see that x can be cancelled, right? So here I got a constant here, that is 2 by 3. And next, we can write, that is limit sine 2x by 2x, x approaches 0, and times limit 3x by sine 3x as x approaches 0, right, guys? And this limit is 1. This limit is also 1. So that equals to 2 by 3 times 1 times 1 equals to 2 by 3. And this is the result of the question number 4. Can you understand? How many of you can understand?
Yes, Laushi, we did.
Laushi, go over.
Not really.
Laushi.
Laushi, say it again, please.
Okay.
Can you repeat last line, Laushi? Last line.
Last line. Okay, here. Here I use product rule. Here I use product rule. So that is equals to limit times limit, right? And this part we use the first formula equals 1. And this part I use the second formula equals 1. So that equals to constant 2 by 3 times 1 times 1. So that is 2 by 3.
Got it, Laushi.
I will explain it again.
Lashi, I have a question.
Okay.
Here for limit sine 2x over sine 3x. If I use these rules, sine 2x equal to sine 2 sine x cos x over sine 3x, that has used to rule, that is 3 sine a minus 4 sine cube a. Actually, 3 sine x minus 4 sine x, 4 sine cube x. Can I solve this problem?
Sorry. Because you are talking about a long formula, so can you type? Can you write on the screen or send it in the WeChat group? So let me see it directly.
Okay, Lashi.
Laushi, with the last line, the limit 3x over sine 3x. Is it the same as maybe sinus 3x over 3x?
Here we first we use the formula that is the first exercise, right? X by sine x approaches 0 equals 1, right?
Yes, Laoshi.
First question, the first exercise, that is this one, and we got the limit that is 1. Here also we can see it as a more general formula. So as long as these three parts are the same, we always have the limit that is 1. So here can be 3x, here should be 3x, and here should be 3x, right?
Okay, Laoshi.
Yeah, so here maybe you can write 3x, and here you can write 2x. But 2x, x approaches 0, and 2x must be approaches 0. Also 3x approaches 0. They are the same. They're the same. So I just now wrote x approaches 0. The simple one.
Okay, thank you.
Okay, about this question, if you have any doubt, maybe you can talk to me after class. And someone want to scroll up? So which question you want to see? Number 2? Or which one? Okay, I will give you the whiteboard after class. And this is the question number 4. And the question number 5, actually, that is similar to the question number 4. Because here we use a formula that is here, number 2.
Lastly, I'll send Anu sir these rules. Please check it.
In the WeChat group?
Yes, yeah,
The last one?
Yes. Something.
Your question is the WeChat group last picture, right? The latest picture.
Yes.
Okay, let me check it. If you use this formula, you will see that you cannot get the limit directly, right? Because although you can rewrite sine 3x, but when sine x cancelled, you also have 2 cosine x by 3 minus 4 sine x squared, right?
Right.
Yeah, so if you substitute x equals 0 into the function, you can get a value, then you can use the formula. But if you cannot use it to solve this kind of question, because that is not useful. And I think that is not simple for this kind of question. Because I can give you sine 5x, 10x, right?
Right, Lars.
Yeah, so you cannot write every formula out, right?
Right.
Yeah, so I prefer this way to solve this kind of question. Okay, guys?
Yeah, Lars.
Yes, Lars.
Okay, so for the last question, last exercise, I will write here. Question number 5, and we use the formula here, as you can see, number 2. Limit of tangent x by x as x approaches 0 equals 1. So we use that result to solve number 5, tangent 3x by sine sine 5x. Tangent 3x by sine 5x as x approaches 0. Here, we use the same way as question number 4. We first change it two parts. Tangent 3x times 1 by sine 5x. Right, this is the first step. And then if we want to use the formula, we should rewrite. Because tangent 3x, we want to use tangent 3x by 3x, right? So we must time 3x to make it the same. So this is the first change I make here. So that equals to x approaches 0, tangent 3x by 3x and times 3x. That equals to tangent 3x. And for the second part here, 1 by sine 5x. If I want to use the formula, there should be 5x by sine 5x. But to make it the same, I must time 1 by 5x, right? So the second part I rewrite as 5x by sine 5x times 1 by 5x, right? And then we can know that can be written as limit x approaches 0, tangent 3x by 3x. I put it forward, that is 5x by sine 5x, and then times 3x times 1 by 5x. And here x can be cancelled. And we can get a constant 3/5 here. So we can take that as 3/5. And here's a limit that is tangent by 3x. And the second, that is 5x by sine 5x, x approaches 0. And these two limits are the same, that equals to 1, right? So that equals to 3 by 5 times 1 times 1 equals to 3 by 5. So this is the solution for the question number 5. And I think that is similar to number 4. So do you have any questions? Or can you understand it better? How I changed the...
Understand.
Okay, any questions? Okay, so let's move on. Let's move on. So above, we have introduced one very, very important formula. So you should remember and you should know how to use it well. That is very important to calculate the limit for this part. And of course, that will appear in the final exam, right? So you should know the formula and how to use it as the exercises I gave you. Okay. Because the questions on the final paper, that will be very similar to the exercises we practice during the class or the homework. So you must make every question clear. And if you have any question, you can talk to me after class. Okay, so let's move on to the next part. Above, we talked about the limit like this. As x approaches x sub 0, the limit of a function of fx, that is L, a constant. And here, x0 means maybe 0, 1, 2, 3, any value. Here, we can see here is 1, Somebody please off the microphones. Okay, here. There is one special case that is here. Sorry. Okay.
He is trying to sing a song.
Okay. Okay. So here we have seen this function before, that is 1 by x. Y equals to 1 by x. And for the graph of this function, that is like this. Okay, and this is the if x is larger than 0 part, and this is if x is smaller than 0 part. For this one, you can see if we talk about x is larger than 0, you can see as x is larger than 0 and x can be bigger and bigger and bigger to enough large, right? So here we call it infinity. So here you should remember one thing, that infinity, this symbol, does not represent any number. It shows the behavior of a function when the values in its domain outgrow all finite bounds. That means it gets very, very, very large, but it is not a number. It is not a number. So here we introduce this symbol infinity. So here we can talk about as x approaches infinity. And for this part, because x is larger than 0, so we call it positive infinity. And here, if x is smaller than 0, so you can see here, x can be very small, very small. So here we call it negative infinity. So here we can see two cases. Number one, that is x approaches positive infinity and x approaches negative infinity, right? And here we consider the limit of the function 1 by x. First, as x approaches positive infinity, as we can see from the graph, if x gets bigger and bigger, we can see the value of y gets smaller and smaller and very close to 0, right? So we know the limit as x approaches positive infinity, that the function, the limit of the function equals to 0. And also here, if x approaches negative infinity, that we can see also the value of fx approaches 0, right? So that is also the limit equals to 0. So now we can consider the limit of a function as x approaches infinity. So that is the next part we will talk about. And the rules, the limit law here, that is very similar to this one. The laws that is similar to the previous law we have talked about. So here you should know what it means as x approaches infinity here. And remember this one, as x approaches infinity, no matter positive or negative, the limit of 1 by x also always 0, always 0. So here we can also get a theorem as before, that is, when we talk about the limit of a function as x approaches positive or negative infinity that exist. We should both have the limit of the function as x approaches positive and the limit of the function as x approaches negative infinity. The limits are the same. The limit should exist and the same. So here we call the limit of the function exist. So here you should know that the definition here that is similar as before, and the way to prove the limit of a function exists that is also similar to before. Okay, here we see an example here. That is this function. We have learned it last week. That is y equals to arc tangent x. Arc means inverse function. We have learned it last week, right? So here, from the graph, I will give you the graph. The graph that is here. This line means pi by 2. And this line means minus pi by 2. And the graph of this function that is like this. This is the graph of y equals to arc tangent x here. So here you will see that as x approaches positive infinity, the limit of this function arc tangent x, the limit that is pi by 2, right? Because the value of y approaches pi by 2. So here, that is pi by 2. But if x approaches negative infinity, we will see that the value of fx approaches minus pi by 2. Yeah, so the limit here, that is minus pi by 2. So from the theorem before, we know that the limit of this function arc tangent x as x approaches positive or negative infinity, that does not exist, right? Because they are not the same. They have different limit here. They have different limit here. So this limit does not exist. So this is things we have learned about the infinity limit. Okay, so here I will give you an example shows the limit as x approaches positive infinity, the limit of 5 plus 1 by x. So guys, can you tell me the limit of this function?
Lashi, can you repeat the previous?
Do you remember? Do you remember this one? The limit of 1 by
5.
x? Yeah. Yeah.
Yes.
Yes. So for this question, we can first use the sum rule, right? So that equals to limit x approaches positive infinity 5 and plus the limit as x approaches positive infinity 1 by x, right guys? So that equals to the first one, the first limit that is always 5 because it is a constant function, right? And this,
Yes.
yeah, the limit of this part that is 0, right? 0. So 5 plus 0 equals 5.
5.
Yeah, can you understand, guys?
Yes, Lashi.
Okay.
Yes, Lashi.
Okay. Okay. So here,
Can you scroll down the page, Lashi? I need a screenshot.
screw up or down?
Yes.
Okay.
Okay.
Okay. So now, please work out. Number 1, 2, 3, I have told you how to solve it, right? We have worked it out. So please tell me number 4, 5, 6, the result of number 4 to 6. And I know the things we learned today is more difficult than last week, right? So please. I'm in the mood for Asian, Southeast Asian. First, do the exercises, do the examples I gave you during the class again to check if you can do it by yourself and get the right solution, including the procedure, not only the result. And then I will give you homework today, but not so much. So you will you can finish the homework, and don't forget to submit the homework before next class. So I will show the homework at last and give it to you in the WeChat group. Okay, guys, practice more. That is the only way to learn it better. And these 3 questions, I think that is more easier. When you write the solution, don't forget to write the equal sign. Every step you should write equal sign. Question number 5, most of you make a little mistake. And so please check it again. I have shown on the new pictures and I sent it in the WeChat group. So check yourself.
Should it be like x squared by 5?
Square by 5. No, number 5. Number 5. Oh, okay. I will show it on the whiteboard because many students make this mistake here. Okay. So number 5. Number 4. Number 4. Question number 4. Do you have any questions? The result of number 4, that is pi, right?
No. Yes.
Yes.
Yeah. So we can skip number 4. Question number 4. Okay.
Okay.
Okay. For question number 5. Okay. Question number. I write it here. Number 5. Question number 5. That is to get the limit as x approaches infinity, 1 by 8 minus 5 by x squared, right? This is question number 5. Some students write like this. I write it on the right, like 1 by 8 minus 5 by x squared, then equals to 1 by 8 minus 1 by x squared, 5 by x squared. And they are not equivalent because we know that a plus b by c can be written as a by c plus b by c, but c by a plus b cannot be written as c by a plus c by b. They are not equivalent. They are not equivalent. For example, 1 by 2. 1 by 2 can be written as 1 by 1 plus 1, right? But obviously that is not equal to 1 by 1 plus 1 by 1. 1 by 1 equals 2. They are not equivalent, right? So it is wrong. It is wrong to write like this, but this is correct. Can you understand, guys? Yeah.
Yes, Lord.
Yeah. So you should know this is not correct. And then for this part, we can use the substitute rule, right? So that equals to 1 by 8 minus here, as x approaches infinity, that the limit 5 by x squared as x approaches infinity equals 0, right? So that equals to 1 by 8 minus 0. So that equals to 1 by 8. although the result is 1/8, they are the same, but you cannot write like this. It is not correct. Can you understand, guys? Okay.
Yes.
Yeah. And for the last question, number 6, we can get as x approaches infinity, that here is -5 plus 7/x, right? By 3 minus 1/x squared, right? Is it the right question? Yeah. So here we know that as x approaches infinity, that this part approaches 0, right?
0.
Yeah, and this
Yes.
part approaches 0, right? So that equals to 5 plus -5 plus 0 by 3 minus 0. So the result that is -5
by 3.
yeah, -5 by 3.
That was so easy.
Yeah.
Now we got the point.
I did not get the
We have difficult part, but we have easy part, right?
Yeah.
Yeah. We will take turns. Not always the difficult part. Okay. And for the last type, as x approaches infinity, that is about rational function. And here, do you know what is a rational functions? Do you know what is rational functions, guys?
Yes.
Yes.
Yes, Raj.
Okay.
1 point something.
Okay.
Yes, I know.
Yeah. The numerator 4x squared minus 3x.
It will be part. It will be repeat and repeat.
This is a rational function, and this is also a rational function, right? So here we consider the limit of the quotient of two rational functions. Maybe one is px, a second is q of x as x approaches infinity. So for rational functions, here we consider these 3 exercises first. Then the first question, for rational functions, we usually
Lasha, I cannot hear you properly. I guess the network problem.
So others, can you hear me clearly?
Yes, we can hear you properly.
Yes,
We
Laushi.
can hear you, Laushi.
Network problem.
Okay. So maybe you can re-enter the meeting. Try it again. Okay. So for the rational function, the quotient of two rational functions, here is the way to solve it. That is, first step 1, we will find the highest power, the highest degree of the rational functions. So first, find the highest power. Find the high. Oh, I will write on the whiteboard. Okay, so this we call it rational function. And for the rational functions, the way to calculate the limit, step one to find the highest power. Find the highest power, both the denominator and the numerator. So here for the question number one, that is the numerator, the highest power is 2, right? And denominator, the highest power is also 2, right? So compare the highest power of the denominator and the numerator, and then choose the highest one. Choose the highest one, and then divide the numerator and denominator by the highest power of x. So first find the highest power, and then divide the highest both up and down, numerator and denominator, up and down. So for the question, okay, I will write the question here. Okay, so here we can see the highest power of both up and down, that is power 2, right? So we divide x squared, both up and down, both up and down. So the question, I will write here the solution here. 4x and 5x minus 1. Okay, so here we found the highest power, that is 2. So we divide x squared here. So the next step, that is 4x squared minus 3x plus 9 by x squared. And together with 5x squared plus 2x minus 1 by x squared. So we first find the highest power, then divide it. And then we separate the function. We can see part by part. The first, that is 4x squared by squared, right? So that is 4. And minus, here we can cancel 1x here, both, right? So minus 3 by x and plus 9 by x squared. Can you understand the numerator, this part?
Yes.
Yeah. Okay.
0.
0.
0? Oh, which part is 0? No.
3 over x plus 9 over x square.
Wait a moment. And for the denominator, we also use the same rule. Write it part by part. So here that is 5 plus here we can cancel 1x here. So that is 2 by x. And then minus 1 by x squared, right? So now we have this new form. And then we will see as x approaches infinity, this part approaches 0, right? And this,
Yeah, last year I told that.
Yeah, approaches 0. And this part approaches 0, this part approaches 0. So the result, that is 4 by
5.
Yeah, 4 by 5, 4 by 5. So this is the result of this question. Can you understand why? Do you have any
Yes,
questions?
last year.
Yes.
No
No questions, right?
Laushi, can you repeat this second step?
Second step here.
Yes, Laushi.
Okay.
Yes. Then
Yeah.
the third.
Yeah. So you first find the highest power, both up and down. So here you can see for the numerator, the highest power is 2, right? Here is also 2, right? So we find that is x squared. Then we divide x squared both. Then we get the second step. We divide the same factor.
Okay.
Yeah, that is x squared.
And after that,
yeah, and then we separate it. We use the formula that is here. A plus B by C equals to A by C plus B by C, right? And
yes,
now here you can see we can write it part by part. This part that equals to here. That equals to 4x squared by squared and minus 3x by x squared, right?
plus 9 minutes.
Yeah, 9 by x squared. And here, x squared can be cancelled, so we have 4 here. And here, 1x can be cancelled, so we have 3 by x here. And the last part is still 9 by x squared. And as x approaches infinity, we know these two parts approaches 0, right? So
yes,
okay.
Laushi, basically, I can realize that minus 3 by x is that 0.
Minus 3.
But I can realize that how can we get minus 3 by x 0 or 9 by x is 0?
That is infinity.
Because it's infinity.
Oh. Okay,
Infinity.
Yeah. As x approaches infinity, we have this result. Okay. So guys, any questions?
No.
Okay. So here you will find one skill to solve rational functions. If the highest power of the numerator and denominator, they have the same highest power. For example, here, the highest power is both 2, right? They have the same highest power. Then the result, the limit of this function that equals 2, we take the constant before the highest power and the constant before the highest power in the denominator, then we divide it. So we have the result that is 4 by 5. You can write the result directly. That must be 4 by 5. No matter which forms I will write in the following. So this is a small skill here. You can check if you have solved this question correctly. Okay, guys. For example here.
Okay, Laushi.
Yeah.
A question.
1 minute. Just 1 minute. Sorry. For 1 minute, and I will give you time to ask question. Okay.
Okay, Laushi.
Okay. For example, here, the exercise number 1 and number 2. Question number 1, you will see both the numerator and denominator, the highest power that is
1,
right? Here 1. Here 1. So the result, the limit must be 2
over 5.
2 by 5.
2 by 5.
You can check after class. And here, can you tell me the limit? What is the limit?
2.
Yeah.
2.
Yeah, that must be 2 by 1. So the limit must be 2. But here you can see they have different power, right? The highest power is different. So you cannot use this skill, and we will learn how to solve this kind of rational functions next week. Okay?
Okay, Laushi.
Okay. They have the same power, and we can use this skill. Okay, so what is the question? So now
Okay, Laushi, the question, I think it will be next week because what I was about to ask is what he said. We will learn about it in next week.
Okay. So about other cases, we will learn next week. Okay, guys?
Okay, Laushi.
Okay, Laushi.
So Laushi, our class is over now.
Yeah.
Oh my gosh,
Thank
our
you,
homework.
Laushi.
Homework.
It's a long time to have.
It's a long class.
Thank you, Laushi.
And this is the homework for this week, and please submit before next time we have class. That is before next Thursday. Okay, guys?
The deadline, ma'am.
Laushi.
Okay,
And
Laushi.
you have to
Before next Thursday.
next
class.
Next Thursday.
and one more thing. You have to write the steps, write the procedure, not only one result to me. Okay, guys?
Okay, Laushi.
Laushi, we need
Okay,
to send
Laushi.
homework to your
And
mail.
please send your
Email or chat?
homework to my email. That is more convenient for me to check who submit. Yeah, and my email is here. Here.
Please,
Yeah, I have told you.
Laushi, give me on WeChat group. It will be better. Give me on WeChat group.
Okay. I will give you in the WeChat group. Okay, guys.
Okay, Laushi.
Okay,
নিউটনের লিবনিজ রে পাইলে পাঁচ হাজার থাপড়াইতাম সত্যি যে ওরা ক্যালকুলাস আবিষ্কার করছে
Okay.
Bye bye,
Bye.
Laushi.
Okay, Laushi.
Bye. Bye.
Bye.
Bye.
Laushi.
谢谢老师。
好，
You can leave that group.
不客气。
Bye.
Hey, leave Maro.
নিউটনের লিবনিজ রে পাঁচ হাজার আবার আন্দোলন করে ওরা কি জন্য আবিষ্কার করছে